Hello, my name is Jorge Vasquez, and I'll be presenting dynamic programming, specifically the knapsack problem. What we'll be exploring in this presentation will be the knapsack problems to be solved. I've selected two. One's very simple and the other's a tiny bit more complex. We're also going to go over the pseudocode so that we can know what we're doing in the algorithm, what the algorithm is attempting to accomplish. Then we'll look at the formula evaluation, which should feed off of the pseudocode, and we can see how the math flows through the problem. We'll be looking at my code implementation. It's done in C++ and the code execution. The two knapsack problems I've selected can be viewed on the left and the right of the screen. On the left side, top, you have the knapsack two items, their weight and value, and below it you have the solution set. On the right side, you have a little bit more of a complex knapsack problem, 4 items and a capacity of 5 rather than 2 items and a capacity of 2. I've selected this so that we can follow the formulas through the left-hand side fairly easily without having to do the repetitive evaluation that the algorithm is going to do for us. So as we get to the formula evaluation, I've thrown in a bit of noise at the top. We'll come back to that. But the formula itself is here in the center. F of ij equals, and you have two options in here. You have an if statement, which governs this max statement, and then you've got another if statement, which governs this f of ij solution. So if we roll back to the last slide, you'll see that here you have an if or an else statement, and that's essentially what we're looking at, is the two if statements are what's guiding the pseudocode down that path. So at the top, I've included the problem, and I've included the first iteration of this code. What it should output to the F table is a -1 set to the 1, 1, 1, 2, 2, 1, 2, 2, and then initializing the first column to zeros and the first row to zeros. Okay, so as we look through the first statement, F1 of 1 gets evaluated by the first two if statements that I talked about. So the actual formula is if j minus the weight of item 1, as we're on I is 1, which is j is also 1. So we have a 1 minus 2, right, which should evaluate, we're evaluating if it's greater than or equal to 0, which it's not because 1 minus 2 is going to yield a -1. So we have to use this second section here, which is this one. Obviously, -1 is less than 0, so our f of 1 minus 1, as we follow this formula here, f is I is 1, minus 1, and j, which is also 1, or we get an f of 0, 1, which currently has it stored in 0, 1, a 0. So this gets returned as the value of f1, 1. So f1, 1 becomes a 0. And if we go back to our solution, you'll see that f of 1, 1 is 0. So as we move on to the second, f of 1, 2, we've incremented j so that we can look at the second set, which 1, 2 is currently set to 1. And we evaluate the same two statements again. So this time the statement evaluates to true, so what we're going to end up using is the max function, which is the top portion of the formula. And so we get f of 1 minus 1 comma 2, and then the second section, which is the value of item 1, item I, which is item 1, which is $12. We put in the 12 plus the f of 1 minus 1 and 2 minus 2, or f of 0, 2. So what we're looking for is the max between these two sections, this section here or this section here. And if we go back to the pseudocode, we can see that that's the same thing that's happening here. The max of this section or the max of this section. Value I is going to be your 12. Okay. So as we move through, we know that the first section, 0, 2, 0, 2 evaluates to a 0. So that is the lowest currently. This section does the value of 12 plus f of 0, 0, which is also 0. So in essence, you have 12. So then we go back and we're going to do, in the pseudocode, we're going to follow this portion here, which is, after this, you perform the max function. F of ij becomes that value. And if we look here, we see that the value is 12. So 1, 2, 1, 2 becomes 12. So we are out of j's to increment, so we will exit that for loop and we'll start on the top level for loop, which we'll see in the code that I've written. And we increment I becomes 2, and we start again, 2, 1. We perform the same evaluation here that we performed before, and the statement evaluates to true, as 2 minus 1 is greater than or equal to 0. So we're going to be performing the max function again. So if we look at this max function, we have f of 2 minus 1, 1, or 10 plus f of 2 minus 1, 1 minus 1. And that evaluates to f of 1, 1, which when we look up at our section, we set that to 0. This is where the dynamic programming really starts to take effect, right? We've already run this value. So when the program is executing, it's going to check back to the F table and see what the value currently is at that location and add it to the value that is associated with WI. So for this one, I is 2, the weight of item 2 is 1. I'm sorry, the value of item 2 is 10. So again, we look at this evaluation of F11 and we know that's 0, and we look at the evaluation of 10 plus F10, which 1, 0 is a 0, so that becomes 10. So F2, 1, which is right here, becomes 10. The next section, we look at f of 2, 2, and we've incremented j again to the last iteration that we can do, and we evaluate again, and that comes to true, and so we execute the max function again. So when we look at f of 2 minus 1, 2, and 10 plus f of 2 minus 1, 2 minus 1, we have f of 1, 2, which is this first portion. 2 minus 1 is 1, and then 2. F of 1, 2, which we know is 12 from the earlier evaluation. And we look at 10 plus f of 1, 1, which is 1, 1 again is 0. So we have 10. So f of 2, 2 equals to 12. And as we go back and look at the solution set, you'll see that we've evaluated 1, 1 of 0, 1, 2 of 12, 2, 1 of 10, and 2, 2 of 12. So this is the end of our formula evaluation. What I want to move on to next is our code implementation. So as we walk through the code implementation, I want to point out a few things. Global variables for the vector weight, vector value, and vectors F table, or vector of vectors F table. The inputs, when they get set and where. And then I want to initialize the vector F table, walk through that. Then we can run the 2 for loops, which sends the f of ij, and starting at f of 1, 1, and then iterate through the whole table. That's going to be the second for loop that does that. And then each time we iterate a version of the table, I'm going to print. So before we get to the code execution, I want to show the display that we're going to get. This should look really familiar because this is how the algorithm initially sets the F table. And then each one of these steps is what we walk through on the formula. You should see, 1, 1, 0, 1, 2, 12, 2, 1, 10, and 2, 2, 12. So let's go ahead and run through the code. So we've set up C++, and I've got include IOStream vectors and algorithm. And then we're using cout, cin, which I'm not actually using, but there's a chance for expansion. This is how I wrote this algorithm, so that if we wanted to expand into user input, user variables, we can. Nline, vector, and max. So the first thing we do is we set the global variables outlined in the pseudocode. So this is vector for item weights, vector for item values, and the vector of vector f tables, which is instantiated with zero, or not zero, it's null. There are no columns, there's no vector of vectors, it is simply in existence until we pass through the initialize vector function. And then we've also got a print table function and the actual mf knapsack function main. Expand this. I have limited working environment for up and down on this, so I'm going to try my best to squeeze it all in here. I'll be expanding and collapsing as we go. Integer main is going to drive this. What we're doing in the beginning is, this is where I was saying, we can make this a user input. Um, Set weight capacity to 2, which is what we've outlined in the slides as the problem set. Here are your values and weights. 1 being the initial, doesn't count the 0 index here. And then you've got item 2. The weight for item 1 is 2, and the value for item 1 is 12. And then for item 2, the weight is 1, and the value is 10. So after we set that, we're going to initialize the vector f table, and we can actually start running through this code. Okay, so we've already set that. We're going to step into the initialize vector. We're going to pass f table and the weight capacity of 2. So what this is going to do is this is going to initialize the same portion of the pseudocode that is outlining the column 0B0 and column or row 0B all zeros also. And we should be able to see f table as it expands. So currently f table, if you look here, it has nothing in it. What we're going to do is we're going to push back a 0 into that, and that's going to be our first f table index. It's 2D vector of vectors. We're going to keep going, and what this is doing is it's setting 0, 0 to 0, and 0, 1 to 0, and 0, 2 to 0, and it's going to continue doing that until it moves on to the next section. So this is going to set all the columns to 0. So let's expand. So we're going to keep walking through. And we've moved on to the next section. I missed it, but pushing the buttons a little too fast. As we come down to this section here, these two for loops are instantiating the rest of the f table to hold a -1. I believe there's a better way to code this, but in terms of functionality, it's working. So I'm going to leave it as is. And as we start looking into f table 0, we'll see that it now has 0, 1, 2. And you look into 1, you'll see that 1, 1 has now a value of 1, and 1, 2 has now a value of -1 also. And same thing for here. So we're going to keep pushing forward. I'm going to step out of this. So as we step out, it's going to continue. So now that we've initialized our f table, we're going to use the next print table function to go ahead and see what our first f table iteration, the instantiation and initialization look like. And we've got nothing too crazy that needs to get in here. This is just the formatting and how we outline it. And as we run through, you'll see that it begins to print our table. And okay, I'm going to go ahead and step out of this now and let that run. Okay, so here's our first table, and this is exactly what was outlined in the pseudocode and what we've seen, when we started to run through the formulations. -1 on 1, 1, 1, 2, 2, 1, and 2, 2. Okay, so as we continue, we are going to enter the for loop. So what this is doing is, this is not quite outlined in the pseudocode. The pseudocode actually pushes us to provide an input, which is this section here. Provide a f of I comma j, and what we're doing here is we're doing that, but we've written it so that it iterates through each instance, which would be 1, 1, 1, 2, 2, 1, 2, 2. And those are all relative to the size of the table, F table. So this is kind of flexible. If we wanted to increase the size of F table, we can, and this should automatically be able to handle it without having to rewrite too much code. So when we go into when we go into MF Knapsack, passing IJ, we should be passing the initial 1, comma 1, as that is the first value set that we're looking for, right? So we're looking for 1, comma 1. So it's going to run through the algorithm, and here's your first instance of the if function, or the if statement, and this is going to be tied to the pseudocode. I can pull that up. The pseudocode, which, as I slide it over, we'll see we have the first if, the second if. So as we pass through this, it's evaluated. The first one, I believe, we are -1. I believe this evaluates to less than the pseudocode 0. And because of that, we are going to make my value equal to, again, the 1 minus 1, which is 0, and j, which is 1, so 0, 1. So what's going to happen as we pop out is it's going to update 1, comma 1 to 0, 1. And let's walk it back. And we're returning F table 1, comma 1. And now we're going to go ahead and print the updated table. Let's step in and write out. So you'll see that 1, comma 1 was updated. Now we're going to reproduce the same for 1, comma 2, 2, comma 1, and 2, comma 2. And I'm going to speed through it a little bit faster. So we continue on our for loop. We are now passing 1, 2. I'm going to step out and print and step out. And there's our next section. So we see that the table was updated 1, 2 with the value of 12, which is what we had in the solution set. And we look at the next portion of ij. Again, we're out of j's, so we're out of j's. We must increment I, which will now become 2, and j will be reset to 1, and we'll be evaluating to 1. So walking it through there. Now we'll see that j is 2 and I is 1, and we can peek at our F table and see what we've updated so far as we continue forward. So we're going to step into the knapsack algo, step out, print the table. Should be able to see the table here. So should be 0, 0, all zeros on the 0 front, and then it should be 0, and then here's 1, 1, which is 0, and 1, 2, which is 12. And then the 2's, which we're evaluating, seems that 2, 1 was evaluated to 10. So we should see that popping on when we print this. So I'm going to step out, which will execute all of the print table. And there's 2, 1, evaluated to 10. We have one more run to execute. Now I'm going to pop into my knapsack, pop out, go to the print table, pop in and pop out, and there's our final value, 12, 12. And this is the exact output that I had posted in the presentation. It's also the control set that was provided in our text in the PowerPoint that was provided during the course for this section. It's just truncated down. What I'm going to do next is run the larger code. I'm going to modify that, and I'll show you how easy it is to modify that with the way that I've written the flexibility of the code. So while I'm working with limited screen space here, I've added the original right-hand side, which I said we'd walk through a little bit more of a complex knapsack problem, not anything too much crazy, but we can update our vectors, and this is where the user compatibility comes into play. We don't have to update throughout the entire thing because we're using a lot of dot size and pushbacks so that the vectors make this program set a little more flexible. I'm going to add in what you see over here. So we've got the weights of item 1, which is 2, item 2, which is 1. Going to add in the weight for item 3, which is 3, and item 4, which is 2. And then I'll update the values respectively. So we've got the item weight, or the values of 1 is 12, 2 is 10, this one is 20, and item 4 is 15. Now, this code should execute as long as we set our capacity to what we want. Again, another potential for user input here. The book's output, I believe, was 4, or at least that was what was provided during the class session, so I'm going to do 5. I'm going to do 4. You can see what that comes out to. Let's restart that. And I'm going to remove all our breakpoints and allow this to run as is. But we got it to compile, so that's the first step. And I'm going to collapse everything. Okay, and continue, and here we go. So let's match this to the solution set. And here we have 0, 1 through 4, and 12, 22, 30, 30, 12, 22, 32, 37. Oh, apologies, there's a 5 there. 12, 22, 30, 30. Now, if we wanted to run it for a capacity of 5, we simply need to go back and change the capacity value to 5. Re-execute the code. The algorithm runs as desired. And again, we look at the final iteration, which is the solution set: 37, 32, 22, 12. 37, 32, 22, 12, and 0. If you look, this becomes more and more dynamic sets are included. So each iteration it runs, it's updating and saving, and this is actually pretty interesting because I think you could do this for very large sets of numbers without getting too crazy as it's written here. And then again, I don't think the conversion for more user input, asking the user if they want to, set the number of items in the beginning and what their weights and what their values are. So this can be adapted for a lot of that. And the last thing I want to cover is my references. I did use the textbook from the course, pulled a few snippets from there. They are outlined in their section, and then I used a little bit of Excel to put together the knapsack problems. This ends the presentation. Thank you for your time. Have a great day.